Welcome to the second part of my discussion about spiral curve, and in this video I'm going to discuss how are you going to solve for the problems with less memorization of formula. So I'm going to concentrate on the geometric properties of the spiral curve. So to understand how are you going to solve it, let us have a specific problem. A spiral curve is 80 meter long and the radius of the simple curve is 200 meter. Here are the question. Compute the spiral angle at SC and at first quarter point. And there are so many questions there. So I'm going to read it one by one as we solve it. So let us just first focus on question letter A. So let me draw first the figure. Here is your figure. This is the radius of the simple curve. And this is the length of the spiral. This is the tangent to spiral, spiral to curve, curve to spiral, and spiral to tangent. But for you to determine the spiral angle, I'm going to draw this in enlarged figure so you can see it clearly. Okay, so let me draw this one. Here is the enlarged image of the spiral part of the curve. So what exactly the spiral angle is? To determine the spiral angle, you should know where are you going to get it. Say for example, you want to get the spiral angle at this specific point. So you must know how far this point from TS. Let me say that this is L. So the measurement should be along the curve. So let me say also that this is the length of the spiral, which is equivalent to 80 meter. So when you say spiral angle, that is the angle formed by the tangent at this point and the tangent drawn at TS. So what do I mean? So in this point, I'm going to draw a tangent line like this. The angle formed by this tangent line and the tangent at TS will be our spiral angle, theta. So the first question is the spiral angle at SC. It only means that you're going to put your point at SC and that L should be equal to 80 meters. And you're going to draw a tangent to SC. And then this angle is the spiral angle at SC. Let me call it theta S sub C. Okay, guys? But how are you going to determine? Actually, there is a formula that you can use to determine it. But if you don't want to use that formula, there is another way. That is by understanding the curvature of the spiral. So let us review how the curvature of the spiral curve changes from TS to SC. Say for example, this is your x-axis and we start from TS. And then this is, let me say that this is S sub C. So that the length from TS to SC is 80 meters. If you want to graph the curvature, let us say that in our y-axis, we graph the curvature K. And you know for a fact that at TS, the radius of curvature is infinite. K is 1 over the radius. So if this is infinite, the curvature at TS is 0. And for SC, the curvature is 1 over 200, R being the radius of our simple curve. So if you're going to draw it, this will be like this. This is 1 over 200. So therefore, you draw a line like this because the curvature changes linearly. So this is how you do it. To be able to get the value of theta at any L distance, let me say this is L, at any L distance, you will just get the area under this diagram. I'm not going to show you how it is derived from calculus just to save time. We will just apply it. So just remember that the spiral angle from TS to any point L distance from TS is basically the area under the curvature diagram of the spiral curve. So if you want to get theta SC, you will just get the total area from TS to SC, which is, that is just a triangle. So that is 1/2 times 80 meter multiplied by 1 over 200 meter. This is unitless. It implies that our unit should be in radian. So that is equal to 0.2 radian. If you want to convert it into degree, you just multiply it by 180 all over pi. That is basically 11.46 degrees. And the next question is determine the spiral angle at first quarter point. So the first quarter point would be the 1/4 distance from TS to SC. So definitely, the first quarter point is located 20 meter from, let me say that this is 20 meter. And this is not to scale. Let me say that this is the first quarter point. Let me call it Q sub 1. And then you're going to get the area. So you can actually get the value of K here, which is technically, you can just use ratio and proportion. Let me show you. This is K over 20 is equivalent to 1 over 200 over 80, which give us a value equal to 1 over 800. Okay? Or just, since this is just 1/4 of 80, you just get the 1/4 of 1 over 200, which is basically 1 over 800. So to determine the theta at the first quarter point, let me call it theta at the first quarter point. This is simply 1/2 times 20 meter multiplied by 1 over 800 meters. So which give us a value equivalent to 0.0125 radian. That is how you get it without a formula. Actually, from this idea, you can derive it. How? You want to get the spiral angle at any L distance. This is L and you have it. Let me say that this is K. So you can use ratio and proportion for that. Just for general rule, let me call it 1 over R, because we're going to derive the value of theta at any value of radius of the simple curve. So therefore, using ratio and proportion, it follows that K over L is equivalent to 1 over R over length of the spiral. K is equivalent to L over R times length of the spiral. And then to get the value of theta at any point, you just get the area of this, which is, this is just a triangle. So that would be 1/2 times the length multiplied by L over R L sub S. So that our formula will become L squared over 2R times length of the spiral. So if you want to get the value of theta at SC, you just make L equal to LS. That is simple. So that this will be LS over 2R. I just show you that you don't need to memorize. Just understand how it happens and it will lead you whatever you want to know. So the next question is determine the offset distance at SC and at first quarter point. So practically, what is offset distance? When you say offset distance, that is practically the perpendicular distance of a certain point to the tangent drawn at TS. So meaning to say, if you want to get the offset distance of this point, you just draw a line perpendicular to TS. And that would be equal to X. That is the notation we're going to use. We're going to use that. And if you want to get the offset distance at SC, you will draw it like this one. This is X sub Z. How are you going to get that? Actually, there is a ready-made formula for that. This is X. That is L cube over 6R length of spiral. So if you're going to use that, L is 80. 80 cube over 6 times 200. And the length of spiral is 80 meter. The answer is, okay, so the first question is the offset distance at SC. So we set the value of L, let me call it X sub C. We set the value of L equal to 80. And that would give us a value equal to 5.33 meters. But again, what if you forgot this formula? And say, for example, you don't want to use any more formula because for you, memorizing a formula is hard. There are many ways to do it. I will show you. One of the technique I'm using to get the value of X at any distance is by using the moment of area. For example, I want to get the value of X sub C. So X sub C meaning I'm going to put a cutting plane here, and you imagine that this one is a load, like a beam. So if this is a load and you want to get the area, you can just get the load. And the load is equivalent to the area, which is equal to 1/2 by 80 by 1 over 200. If you want to get the moment here, you just multiply 1/2 80 by 1 over 200 by 1/3 of 80. So that is 80 over 3. So this one will give us, we have the same answer, 5.33 meter. So that is another way to get it. That is a technique I'm using. But there is another technique for that. And I want you to follow this next technique, because you can use this technique not only for X but for all other questions, and we will dig deep into that. So this is a relatively easy thing to do. Remember, theta is L squared over 2R L sub S. This formula is easy to derive. Or you want to get the value of X. If you already knew this one, there is no need for you to memorize the value of X at any point. What are you going is just integrate this function, L squared over 2R LS dl. That is always dl. From 0 to L, to the point you want to get the value of X. So, if you want to get the value of X sub C, as I said a while ago, integrate L squared over 2, what is the radius? 200. And the length of a spiral is 80. And then, since you want to get the X up to SC, you just integrate from 0 to 80. Okay? So, if you're going to press it in our calculator, and then the answer is the same as 5.33 meter. And, hey, the next question is, you want to find out the value of X at the quarter point. So if you want to get the value of X, let me say, for example, that this is 20 meter, which is the first quarter point, and you want to get the value of X, what you are going to do in your calculator is, instead of 80, I'm going to change this 80 into 20, which is the 1/4 distance from TS. Again, so in your calculator, replay it, and then you just change this 80 to 20, and then press equals. And the answer is 0.083. Okay, that is how you do it. So for me, if you already knew the formula that theta is L squared over 2R L sub S, you just use it, and then if you want to get the value of X, you just integrate in your calculator. Less hassle. So next question is determine the deflection angle. I will let you solve this because this is very easy. How are you going to get the deflection angles? This is TS and this is SC. This is the tangent line. What is the deflection angle? Say for example, you want to get the deflection angle of this point. You draw a chord from TS going to this point and calculate this angle. Let me call it as letter I. To get the value of I, you just use this relationship. That is theta all over 3, wherein theta is practically the spiral angle. So you draw a tangent line and you get the value of theta. And I taught how to get the value of spiral angle at any point. You just divide it by 3, and that is now the value of the deflection angle. I want to concentrate on the next question, which is determine the length of short tangent and long tangents. Look at my figure here. When you say short tangent, that is the distance from SC up to this one, up to this point. So I will label it this one. This is your short tangent. And the long tangent is the distance from TS up to this point. So therefore, this one is the long tangent. Short tangent is very easy because we already calculate the value of X sub C, which is equivalent to 5.33 meters. And we calculate that the theta at SC is equal to 0.2 radian. And 0.2 radian in degrees is equivalent to, this is 11.46 degrees. So let me put it here, 11.46 degrees. If I'm going to consider this right triangle, it follows that the value of sine of 11.46, which is 5.33, all over the short tangent. So therefore, short tangent is equal to 26.83 meters. This is now the length of the short tangent. And now, how are you going to get the value of the long tangent? Before I solve the long tangent, I'm going to introduce again another value. And let me use y as a notation. So, what is that y you are talking about, sir? Okay, say for example, again, this is your spiral curve. This is tangent to spiral, and this is a spiral curve. Spiral curve. When you say the value of y, that is practically, at any point, that is the distance from TS towards the foot of the perpendicular of a certain point, L distance from TS. Let me say that this is y. Why do I need to get that? Actually, if you want to get the long tangent, you're going to get the value of y from TS up to the foot of perpendicular at SC. So meaning to say, you're going to get this value. Let me call it y sub C. Actually, there is a long formula for that. To get the value of y at any point, here is the formula. That is L minus L to the fifth over 40 R squared LS square. Let us try to get the y at C. L, which is, of course, since we're going to get the value of y up to the full length of the spiral, that would be 80 minus 80 raised to 5 over 40 times 200 square times 80 square. So definitely the value of y is equal to 79.68 meter. And why do you need to get the value of 79.68 meter? Because if you already knew this, then you can actually get this because you already the details on this right triangle. So if you get this, you just subtract the value of this to the value of SC, then you have the value of the long tangent. But this formula is very long. I will show you the technique on how are you going to get the value of y without memorizing this. To show you, let us review some of the previous formula that I taught you. And finally, guys, you can also use this immortal formula to get also the value of y by integrating it again, L squared over 2R LS. But this time, you have to put cosine in the front from 0 to L. I'm not going to derive, I will just use it to save time. Let us see if this really works. Okay, y integral of cosine x squared over 280. And since you're finding the value of y from TS to SC, that is from 0 to 80. Let us show this in the calculator. Before integrating, make sure that the calculator is in radian mode. So you just press shift, set up, and press number 4. And then you integrate cosine of alpha x squared over 2 times 280. After typing this, press equals, and the answer is the same, 79.68 meter. So you see, the answer is the same. And then of course, if you want to get this value, that is very, very simple. Let me say that this is letter A. So from the triangle, we all know that tangent of 11.46 is simply opposite over adjacent. So that is 5.33 all over A. So that A is equal to 26.29 meters. Therefore, we can now get the value of the long tangent, which is equal to 79.68 minus 26.29. You have an answer equivalent to 53.39 meters. That is the value of the long tangent. But I have another survival technique. Again, guys, this is not a exact solution, but this is just a survival technique. If so happen, if you are Say, for example, you are just taking a multiple choice board exam, licensure exam. How are you going to get the long tangent if you have no time left in your examination? If you don't have much time, you can use the survival method. That the long tangent is approximately equivalent to the 2/3 of the total length of the curve. Somehow it's near. Let us just hope and pray that there is a choice that is very near to this answer. So let us try. 2/3 of length of the spiral is 80 meters. So the 2/3 of 80 is 53.33. For example, one of the choices is 53.39. Of course, 53.33 is practically near to 53.39. But don't use it if you have much time left. You stick to the proper way to solve it. You solve for y, you solve for this, and you get to solve this one. So, I hope guys you learned a lot about this. Of course, our problem is not yet finished, and I'm going to continue it in my part 3 of the spiral lecture series. Thank you very much.